how much living to over 100 is due to genetics and how much of their lifestyle and environment?
The first part is you're absolutely right. The environment seems more important. I would regret it if I wouldn't say at this point, every one of us at every age can maximize his health and health span by doing exercise.
The professor in the Department of Endocrinology Medicine. He's also the Ingeborg and Leon Renner Chair of Aging Research at that very college, and he's the founding director of the Institute of Aging Research.
Dr. Nir Barzilai, an endocrinologist and geroscientist.
Professor Nir Barzilai, who is the #1 authority when it comes to metformin and aging, and who has been studying metformin since the 80s. He's also the founding director of the Institute for Aging at the Albert Einstein College of Medicine.
You mentioned diet. What is that diet? What is ideal?
So this is another answer that we might not know or even not ever know, but we'll probably could make a good guess.
Does it make sense to reduce the growth hormone so that way your body can mainly focus on living longer and health span?
We didn't take our population because there are too few of them with too few follow-up. We took this population and we asked, what's the relationship between the growth hormone level and their being sick or dead?
One of the most interesting things about you, to me, is that you're studying centenarians. I think you're studying over 500 centenarians, people that are living over 100 years old. So what are some common traits, among those people?
Yeah, you read an old CV of mine, but it's 750. And it's not only centenarians, it's their families. And not only that, we're extending this study, and it's an opportunity. And if you could put a link, we have the Super Ager Initiative that wants to get 10,000 centenarians and families to basically sequence their DNA and find all the longevity genes that we can. This is genes that will slow the aging process. So let me back up now and tell you and answer your question. So look, one of the things that happened when we started looking at aging is we either intervene or found animal models that live long. And we try to see what is it that by a simple manipulation, you can live much healthy and much longer. And it kind of populate. We don't know still everything we need to know about aging, but we know that we can do certain things and have a huge impact in our health. And the centenarians are people who live, when I started in 1998 to look at 100 years old, so they were born in 1898, right? Life expectancy then was about 40. Okay, so they more than doubled their life expectancy. Okay, most of the centenarians that I see today, when they were born, life expectancy was 60. They still got pretty much more longevity. And the first thing we wanted to know, really, it wasn't the first thing that we found, but the first thing we wanted to know is, okay, are those people getting diseases when all of us getting diseases, which when we're in the 60s, and now they live longer with disease? Or is their health span and lifespan, does it go together? And we found that they live 20, 30 years healthier compared to our control. And this wasn't really even the interesting part. The interesting part is not only they live longer, but they have, and I'm throwing a medical term, that's called compression of morbidity. They're sick less time at the end of their lives. Even the CDC, and I think all our listeners know what the CDC after COVID, the Center for Disease Control, have looked at the medical cost in the last 2 years of people who died over the age of 100 compared to people who died in their 70s, and it's third the cost. Okay, so we started talking about longevity dividend. And then we had a professor of economy, Andrew Scott from London School of Economy, who said, guys, you don't know even how to count from an economical perspective. We said, what do you mean? He said, okay, so those guys are not in the hospital, right? So they don't have medical costs. But what are they doing? They're traveling, they're shopping, they're getting houses for their kids. So in fact, their economical value is like $380 trillion until 2030. Because healthcare is such a big care of our economy that if we can find out a way to live healthy, and die, this would be good not only for us, the individuals, or the older adults, but for everyone. So that's what we found in centenarians. We found an example of people who live significantly healthier and longer. And could we imitate that?
Wow. So that is really exciting. And there's so much to unpack there. So, I often hear, or whenever I tell people, like, I've been really, really obsessed with longevity, right, for quite a while now. And I tell people about how we could live to over 100, 120, 150. The possibilities are endless. The immediate reaction that I usually get is, well, why would I want to be sick and live that long? And what you're saying is that not only do they live longer, but they live a healthier life. And so once if you kind of try to live longer, does that immediately mean that you're trying to also live healthier? Like, are the approaches the same, or are the approaches to health span and lifespan different?
They're pretty much the same. So let me explain. So you're right. When I started my career and says I'm interested in aging, people said, "Well, too bad for you. We don't want to hear anything about it, right?" And I thought, "Oh, just a minute." But I'm looking at exceptional longevity. So I'll start using the word longevity, and people heard longevity and they still weren't impressed. And I realized why. They assume that means you have the disease and you live many years with the disease, right? You get Alzheimer's and then you're alive for 20 years. That wasn't attractive to them. And really the buzzword that we're using now is health span. This is what we care about. So it's health span. But I want to say something. So when you said we could live 100 years old, I'm all for it. And I predict that you will be able to achieve that. When you say 120 and 150, I'll tell you something. Our maximal lifespan as a species is 115 years. It's a statistical thing. And there's somebody who lived 122, maybe more than one person who lived 122, but it's a statistical value. It's 115 years. Let's even call it 120 years. And we die before the age of 80. So we have 35 years that we can realize. And I'm saying it just because it's not that maybe we will be able to live 150 and 200 and more, but it's a different, it's going to be a different intervention that we don't have now. Not that I disagree with you. I think it's a different timeline, what we can achieve soon and what we can maybe achieve later.
Yeah, so there's different phases, right? There's different problems we need to solve first. The first problem is, getting to that, realizing that those 35 years.
Right. Well, it's not two problems, it's three problems. Look, first of all, you have to get to aging, right? So you shouldn't get cancer, you shouldn't die in an accident. There are several things that we have to do in order to get there, right? You shouldn't be alcoholic, you shouldn't be on drugs, right? You shouldn't smoke tobacco. So there are several things that we need to go in order to get in aging. If you get to be old, there are several things, an increasing amount of things that you could do in order not to get older, okay, and stay healthy.
Mm-hmm. So as far as the longevity genes you mentioned, one thing that I know a lot of people kind of talk about is how much environment, the distinction between like environment and also genetics, right? And so with these centenarians that you're studying, how much of living to, over 100 is due to genetics, and how much of it is due to their lifestyle and environment?
Okay, so let's break it. The first part is you're absolutely right. The environment seems more important. I'll tell you why, not in my mind, but they seem more important. And I would regret it if I wouldn't say at this point that every one of us at every age can maximize his health and health span by doing exercise, by doing some kinds of diets. So we can talk about which specific, but at least not be obese, right? On sleep effectively, and have social connectivity. All those are environmental things that interact with our biology. Okay, so I want to start by saying you're right. Environment is very important. I don't think that interaction with the environment can get us to be 100. I think we need more help here.
Mm-hmm.
So if it was the board of gerontology and the question was how much environment and how much genetics, the answer will be 80% environment and 20% genetics. It's not really a good question. It's not really a good answer. And there's not really good studies to suggest that. But for me, the major issue that we should know is that it's not that 20% of the people can go to this side of the room and 80% to the other side, because the environment interacts with our genetics. Okay, so if we can find the 100% of this 20% genetics, we might be able to protect from the environment, right? That's the thing. So I'm not sure this obsession with how much is really important if you know the biology. But I would say that it's probably the opposite. In centenarians, it's probably more like 80% or above it in centenarians and 20% environment. In fact, our centenarians, almost 50% of them are overweight or obese. 60% of the men and 30% of the women were or are heavy smokers. Moderate exercising like biking or housework or walking is less than 50%. Vegetarians are a little bit over 2%. That's hard for me always to say, because when we publish this paper, and this paper proved, but the paper was important for us to say, no, those guys are not because they interacted with the environment. It's not that they did what we should all have done beginning 100 years ago. It's not. They've done the wrong thing because it didn't matter for them, because they had genes that slows their aging to an extent that it wasn't important for them. You know, I have a family who, 4 siblings who were born between 1910 and 1920 in New York City. All of them lived beyond the age of 102. In fact, the little sister died at 102. Everybody was shocked, okay? The old sister lived to be 110. When I saw her, when she was 100 years old in New York City, she opened the door for me and she was smoking. And I said, Helen, nobody told you to stop smoking? And she said, you know, all the 4 doctors that told me to stop smoking, they died. And the point is, I mean, to her, I say, you know, who knows how better you would be if you didn't smoke, right? Maybe she died at 110. She could have been maybe 122, right? Mm-hmm. But she says, you know, if you smoke 90 years, you live long life. And she's right on that, except that it's not you're not going to get to smoke 90 years, mm-hmm. statistically talking, right? So this is kind of describes them as, no, it's not about the environment. For example, their children, we're following their children, and the control for the children are those that they are married to. So they share the same environment. And of course, the children are 70, 80 years old, right? It's the children of centenarians. And the offspring of centenarians So I shouldn't say children, I should say offspring. The offspring of centenarians have exactly the same, let's call it environmental features, same macronutrients, same body mass index, or weight adjusted for height. Everything is the same, but they have half of the cardiovascular diseases, and half of the cognitive decline, and half of the mortality. Okay, so you can see that the genetics is even playing in their children. The children are on average 10 years younger than the control group. So the genetic in those guys is remarkable and important.
So do you ever feel like having mixed emotions whenever you release a study? And what I mean by that is, if you release something, let's say the study finds out that it's mainly genetics for these people that live over 100, right? They have these longevity genes, and so there's not much you can do for them. And when people hear that, they're like, well, see, it's all genetics, I don't need to do anything. If I have it, I have it. If I don't, I don't, right? And so I could see some people feeling demotivated of doing things in their control to maximize their lifespan and health span. So do you ever feel kind of mixed emotions?
No. And so let me tell you why. And of course, the people who made, and Jay Leno did a whole thing about my study saying the secret for longevity is smoking and drinking and being obese, and of course, no. For 1 out of 10,000, that's how many centenarians we have, it didn't matter. For the rest of us, it mattered. But okay, when centenarians come to me and say, what do you have for me? I have to try not to laugh, because you're it, I have nothing for you. But for the others, the fact, I think what people don't realize, the reason we find genes, and when I say genes, let me just clarify, it's not that everybody has so many genes and 1 out of 10,000 have a longevity gene, okay? We all have the same genes, but on those genes, there can be changes in the letters of the DNA that cause the function of this gene to change. It can be overactive or underactive, but it's going to be functional, okay? Something is going to happen. And that's what we're finding in centenarians. Now you're saying, oh, you're finding genetic things, so you have to do a genetic treatment? And the answer is no. We'll develop drug, okay? The genetic is to find the mechanism. Then it's a drug development. You usually don't need, for any of my discoveries, you don't have to plan a genetic therapy. To give you the perspective, last year, from FDA-approved drugs, 2/3 of them were based on human genetics. When we looked at mice and we thought, oh God, we understand everything at mice, it must be also applied to humans, we failed a lot, okay? We fail less when we find genes in humans and we can design drugs, and we already know that basically if the drug is going to be right, is going to have the same effect, we already kind of know the results. That's why it's so important. That's why it's so important. If you guys are listening and a grandpa or somebody else who's centenarians, send them our way. It's very important that we'll find everything we can.
Absolutely. And we're going to put the link in the show notes, Nir. So let's talk about longevity genes. And so, you're talking about how there's new drugs, 2/3 of drugs approved by the FDA are targeting genetics. So I had Dr. Vera Gorbunova, and her team is studying sirtuin-6 and how that might be a great activator for longevity. What are your thoughts on sirtuin-6, and also, what other genes do we need to take into account?
Okay, so the sirtuin 6 was found in my centenarians, right? Vera Gurbanova. You might not know it, but
awesome.
So and 36 was really the first sirtuin that showed to extend health span and lifespan in animals without doubt, reproducible around the world. So I believed in 36. In fact, I recently joined the board of a company that I think has the right approach to increase 36. And by the way, this approach is through mRNA. Remember the vaccine, the COVID vaccine, to actually send this gene in like a vaccine, but it's going to go not to the immune system, but to the liver, and then it's going to do miracles. So yeah, absolutely, I agree. However, I want to tell you, so there are many ways to be centenarians. I said that. Actually, one of the not common way to be centenarians is through 36. There are only 2 centenarians that had this mutation, okay? It's important for them, we believe, but it's only 2. The most common way to become a centenarian is to have a mutation that decrease the functions of our growth hormones, okay? Now, we have one growth hormone, but actually we have lots of growth hormones. And 60% of our centenarians have functional mutation in any one of those growth hormones. It's the most common thing. And it makes sense. Why does it make sense? Because when we are young, we want to grow, to be strong. We need to go through reproduction. It's all kind of important to determine the growth and to spend energy in growth. But when we're old and we're starting to break down, it makes no sense to continue our growth. We have to shift the energy to stop the breakdown that we have with aging. And so if people were born or have mutations that decrease their growth hormone levels, they're much more likely to be centenarians. In fact, after we found it in centenarians, we took a drug that was designed for humans. It's an inhibitor of one of the growth hormone, a major growth hormone. And we took it now back to mice. And when we gave old mice this antibody against growth hormone, against the receptor of growth hormone, never mind, but it's against the action of growth hormone, they lived much, much healthier and 10% longer. So we kind of went to centenarians and back to mice, and we kind of proved the concept that this growth hormone pathway is very important. That's the most common example. One of the rare example is 36.
So there are drugs that will reduce your growth hormone once you're old.
Well, the drugs that were developed to fight cancer because cancer express those growth hormone. But it failed in cancer therapy. And we're suggesting maybe there is an alternative, okay? Maybe we can stop aging that way. But also, I would tell you there's a common drug who is a very potent, we call it gerotherapeutics. It treats aging. And it's called metformin. And one of the things that metformin is doing is decreasing growth hormone. And this is important in aging. People who take metformin when they're young, they have lots of trade-offs. It also lowers testosterone, some other things that we don't. But when it comes to aging, it's one of the things it's doing. So there's an example of existing FDA-approved drug, not for aging, but for anything.
Right. So at what age does it make sense to reduce the growth hormone so that way your body can mainly focus on living longer and health span?
So we actually did an interesting study where we didn't take our population because there are too few of them with too few follow-up, but there's a UK biobank, okay, which is the most sophisticated in the world. They have hundreds of thousands. They have millions of people, but hundreds of thousands that they also have the measurement of growth hormone. And we took this population and we asked, what's the relationship between the growth hormone level and their being sick or dead? And when they were less than age of 50, the higher the growth hormone, the better they were protected from diseases and death. And then it switched in 50. And when you get to 60, 70, the lower the growth hormone, the higher the probability that you'll have no disease and death. This is an example to something that we kind of knew about aging. It was called the antagonistic pleiotrophy hypothesis of aging. The things that are good for you when you're young can turn against you when you're old, right? If you have growth hormone when you're young, it's good. If you have growth hormone when you're old, it's bad. If you have a lot of cholesterol metabolism when you're young and you need it for your gonads and brain and stuff like that, it's good. If you're stuck with high cholesterol level when you're old, you're going to get coronary disease, right? So I think it's kind of the same part of the same hypothesis when growth hormone is bad for you when you're old, but good for you when you're young, and it's somewhere where it crosses. And by the way, why to say an age is not enough? For the simple reason, we have our chronological age, right? Our birthday, our driver license age, our passport age. But our biological age is different. And maybe you don't see it when you look at your friends, but if you look at your parents and their friends, you'll see that some of them are much younger and some of them are much older than what you would think. Sometimes 20 years difference, it looks to you, because it's real. And so we can say the chronological age, but it's really individual for everyone.
Mm-hmm. And so because it's individual, what would you recommend for people to do? Like, should they get like an epigenetic test, and then measure different parts of their, organs and their blood and their, genes? How do people kind of tailor it to their specific,
Yeah.
sort of,
so you're
variation?
really asking a question about biomarkers of aging. We know cholesterol is, if cholesterol is high, you're at risk for heart disease. We actually know how cholesterol causes heart disease. And we know that if we decrease cholesterol, we'll prevent heart disease, right? What is the aging cholesterol? And the answer is that we have lots of approaches and it's coming together, but we don't have this agreement yet. In particular, the most important biomarkers, it's one thing to know what's your biological age, but it's another thing to answer what you just asked. If I come and say, I want to improve my age, what should I see that's changing? This is harder. A lot of the epigenetic clocks are not changing, and not changing definitely in a short period of time. So, but I don't think epigenetic clock is the best clock. Eventually, I'm dealing a lot with proteomic clock, the levels of your protein in your blood, and they're very suggestive of what's of relationship to diseases and to mortality. But also there are metabolomic clocks. There's a lot of things. I can throw lots of names, but we're all trying to bring it together to a consensus so that we can give you a good advice. But there are things that you don't need to get, you can improve, you don't need to get the clock. right? If you did 7,000 steps today, you should really do 10,000. And this is in the Fitbit, this watch, this clock. If you gained weight and you're overweight, you know what to do. If you don't sleep effective at night, well, you have to stop binge watching or something and spend 8 hours in a dark room without your machines and improve your sleep. And if you're not socially active, then go and be socially active. And, you know, those are things that everybody can do without clocks.
Absolutely. So you mentioned a few things there, like getting enough sleep, like social connectiveness, exercise, making sure you're not overweight. And then in the beginning of the podcast, you mentioned diet, and you know, there's a particular diet that will increase health span, lifespan. So what is that diet? What is ideal?
So this is another answer that we might not know or even not ever know, but we'll probably could make a good guess. Because remember, you know, when people are saying, well, vegan is good, it's good to people who practice vegan diet who also do other things. And it's not good for everyone either. You know, there are people who do vegan diet, and since it really means that you're going to have more carbohydrates, then you're going to actually gain weight on vegan diet, and it's not going to be good for you. Okay, so it's personalized, and it's not really studied in a controlled way of, you know, you do vegan and you do regular, and let's see the differences. There are differences that you can measure in short time, but not for aging or longevity. So what I want to tell you is where I am on the diet and what I felt made a huge difference for me. And it starts with the fact that when I started to do my aging research, I looked at caloric restricted animal. If you take a bunch of animals and turn them into two groups, half of them eat whatever they want, and the other half get 60% of that. Okay, it's caloric restriction or dietary restriction. They would live 40% longer and much, much healthier. Okay, so people took it to mean that you should have less for breakfast, less for lunch, less for dinner, just have less food. Okay. That's not what we did with the animals. We used to come in the morning and give them the food for the day. The caloric restricted animals were hungry because they get less food, so they ate everything within 20 minutes or an hour. And then they were fasting for 23 more hours. So it's really caloric restriction and fasting. When we gave them the same amount of food throughout the day, they were leaner, but they didn't live much longer. So the fasting is a very important thing. And that's where this idea of intermittent fasting came. And I myself, I would say religiously, although religiously is obsessive, and I'm not sure I'm obsessive, but I'm just every day, I basically skip breakfast and I don't eat for 16 hours. If I finish dinner at 8 p.m., the next meal will be after 12 p.m. the next day. And I'm having a diet sodas, I'm having water, I'm having coffee without sugar and milk, but I'm not eating anything. And that has improved. It made me lose weight in a very good way. I lost my abdominal fat, and it improved a lot of functions, you know, clearing my head in the morning. It improves lots of function that I could appreciate, and that's why I'm sticking to it. And this is not about weight loss. This is about aging. Okay, so if that's a plan for weight loss, men will lose more weight than women, but for me, it's about aging and not about weight loss.
Yeah, I've been doing intermittent fasting as well for probably over 8 years. And I found very similar benefits, you know, kept me lean, more mental clarity, weight loss. and it's just easier, for me at least, to just skip a meal in the morning and then do it at, eat lunch and then dinner. And so I'm kind of curious, you mentioned that in the study, even if they're having the same amount of calories, if one group eats within a certain amount of time, via intermittent fasting, they live longer. Why do you think that is?
Well, you're asking what is the extra benefit of fasting, and we're trying to get the time course of that. In other words, take old and young people and fast them for 24 hours. And because the 16 hours is our invention, okay? I actually don't think that 16 hours is the full benefit for me, although there are benefits, but there's a lot of biology that happens. There's our cell's ability to do autophagy, the insulin level goes down, there's a switch from a carbohydrate to fat metabolism, there's ketosis, there's a lot of things I can throw to you that we're trying to understand better in humans and the time course. And I think the time course for young and older is going to be very different.
Mm-hmm. And as far as timing, you mentioned, 16 might not even be the best one. What is, is the, first of all, what is the best time if, you guys have found that out? And then also, is there a point of diminishing returns where too much fasting is not good? Because, you start to break down muscle and et cetera, et cetera.
Yeah, it's really good question. So for the first question, no, we don't know what's good. And that's why a lot of us, I'm doing 16-8 every day, but there are people who are doing 24-hour fast once or twice a week, okay? Some of us were doing 5 days fasting 3 or 4 times a year, okay? There's lots of variation of what we can do in order to get the full effect. So I really cannot be more insightful than this.
Mm-hmm. Just fasting. Fasting is good. Yeah. Okay. Now, earlier you mentioned training the next generation of doctors, to be more focused towards longevity. And so, how much of that is like preventative medicine, like where you're preventing all of the diseases through certain interventions versus, focus on the symptoms?
Right. So look, our life expectancy in throughout our evolution, let's say it's 100,000 years, we're debating it, right? 100,000 years, it was between 20 and 30. And it's really only in the last 150 years that we made this progress. We tripled our life expectancy, right? And so this is a major achievement. Of course, what happened is we found ourselves after the age of 60 accumulating diseases and their treatment, and the diseases are bad and the treatment are antagonistic, and we end up with a bad quality of life. And we, in order to, and by the way, those diseases were not part of evolution. During evolution, people didn't die from heart disease and Alzheimer and cancer and diabetes, okay? That's not what humans die from. So it's kind of new disease. And what happened, the government decided to create this NIH, National Institutes of Health, to treat those diseases, okay? But the major thing that we've done is we've done prevention. That's why we tripled our lifespan. We harnessed agriculture, we cleaned the water, we built sewers, we did vaccination. All were preventive measures to extend health. And this is how we're looking at aging. Aging, we have to intervene with aging before we have the disease. That's when we have to interfere with aging. And this is how we have to look at it. And this is how we need to create the next generation of doctors. I'm in a campaign now that's held by a philanthropist, a big philanthropist. His name is Sami Segol, who, and I talked today with the dean of a medical school, and I said, you know, basically, and by the way, those National Institutes of Health are National Institute of Disease, right? There's the National Cancer Institute, the National Institute for Diabetes. Okay, those are disease. The only institute that deals with health is actually the National Institute for Aging. Okay, and the idea is we have to stop doing medical school. We should do health school. Okay, it's a better investment to do our medicine when we're healthy, when we can do the prevention of the diseases, rather than teach everybody to treat the diseases when they're too late. And I think that's how the future looks. The future looks like we will have a technology, right? I'm wearing 2 clocks here, right? 2 watches to monitor my health. I have apps that are helping me in that. And this measurement can be able to tell me, hey, did you notice you have fever now? Okay, what are you feeling? And you should know, because in 2 days you'll be sick, right? So I can monitor my health better. They'll tell me, why didn't you walk the same steps you walked 2 days ago? What's wrong with you? Why don't you walk? It's time for your blood test. Do the blood test. If my triglycerides are high, my doctor will get a note about my high triglycerides and will prescribe to me. You don't have to see me, okay? I don't think doctors need to see you often. I think probably nurses can deal with the administration of that, but a lot, and there'll be medication that at certain age with certain requirements you would get. And this technology and this form of medicine and technology will keep you healthy. Now, it doesn't mean at the end of their life we won't get disease and we need to have to treat disease, but the idea is that we'll have less in the hospital and more outside of the hospital treating our health.
Mm-hmm. Yeah, that's really exciting, the future of technology as it relates to health. I remember quite a few years ago, I ran into a startup company that worked in the same office, and they were coming up with a concept where it was a refrigerator and it could analyze based on your health what foods would be best from your refrigerator to eat in that day versus, you know, hey, avoid this. You know, you probably don't need any more sugar from your refrigerator. Don't eat this instead. And so I thought that was really, you know, really interesting for that time. This was like 5 years ago, you know, but yeah, you're starting to see a lot more technologies like that. You know, I'm wearing a watch as well. I'm wearing a Whoop band that, you know, measures my HRV and sleep and, you know, strain level, recovery, all that stuff. You know, if I'm drinking too much, it tells me, hey, slow down, you know, because it's affecting your sleep. So yeah, it's.
I lost you. Okay, I lost you for a second, but I heard you.
Okay. Oh, it says my, hold on. It says my internet is unstable for some reason. Can you still hear me?
Yeah.
Okay. Yeah. So, Nir, what, you mentioned that you have 2 watches. One is a Fitbit. What's the other one?
The other one I got to really try and figure out if it's okay. I got it as a present, but it's called Dido. It's Chinese. I don't think you can get it here now. Maybe you can. And what it does above the Fitbit, it measures my glucose and my blood pressure with the laser technology. And I'm trying to figure out, I'm trying to measure my blood pressure. I have a glucose monitor to see if the glucose is right. And I'm not sure it's an exact, but you know, sometimes it's not about being exact. It's about using the same technology that depicts changes, you know? So, okay, maybe my blood pressure is not 110/70, but if it goes to 130/80, I'll probably know that this is not normal for me with this watch, right? I think it's the same with Fitbit. I'm not sure if it measures my REM, sleep well or stuff, but I'm assuming that relatively it measures the same thing. So maybe it doesn't tell me how much REM sleep I have, but if I have less, then probably I had less, no matter the absolute number. And I think that's the case with also biomarkers. I don't know if they predict your age, but if they change, you hope that it's meaningful.
I see. So besides having a Fitbit, and the other wearable, and then also intermittent fasting, what else? What does your regimen look like? Your longevity, protocol look like?
So, I talked with you about exercise, nutrition, sleep, right? Social connectivity, I'm okay. That's not a problem for me. So what I'm doing in addition, I'm taking metformin. Okay? And I'll tell you another thing, just because I don't want to avoid if something is coming out. I have my own longevity doctor, so I'm not treating myself, although I can. I'm an MD, but I'm not treating myself. But I'm trying other things when I'm doing tests before and after and noticing if I have changes so that I have my own experience. But this is not for the public. I don't think that N equal 1 experiment is helpful. So I'm doing really mainly things that I think are good, and I'm experimenting with things that maybe some of them are going to be good for me and some of them are not, and some of them are going to be bad for others and some are not. But I don't care to talk about that.
I see. And so when you're measuring yourself, like you mentioned, you're measuring it through what? Like, how are you measuring your longevity?
Oh, but by the technology and by blood testing mainly.
Got it. Okay, blood test.
Including clocks.
The glucose clock. Okay, awesome, great. So, before we wrap up, like, if you had to kind of summarize, just all the big things we talked about here, what are the highest impact things people can do to increase their lifespan and health span, if you had to rank it?
So I think I was actually ranking it when I said that. Exercise, I think, is the most important. And again, you can say, what's exercise? Do I do a treadmill, cardiovascular? And the answer is probably you need to exercise your body, you need to stretch, you need to condition everything, okay? It's not that only cardiovascular is good. I have a trainer twice a week to do my upper body, and every day I do aerobic, okay? And I think it's the mix that really is very important, and that's the highest priority. Then it's nutrition, sleep, and social connectivity. So I repeated it more than I really cared, because I really wanted to tell that that's not all that's coming, okay? And remember, even that, not everybody can do. Look, I'm a diabetologist, so once or twice a month, I'm attending in a fellow clinic. And I will tell you that that's in the Bronx, New York. And I tell you that every newly diagnosed diabetic, we're telling him you have to exercise and lose weight, okay? And how many are doing that? Maybe 3%. So I think that we'll have to have combination of exercise and drugs in order to achieve our goals. Not everybody can exercise, and not everybody can diet. And even with a diet, so you tell them to eat fruits and vegetables, but maybe they cannot afford it. You're telling them to eat fish. They don't like fish, right? You tell them to exercise, but they don't have a gym near, and they cannot afford the gym, and they cannot afford the treadmill. So, there's metformin that is the cheapest drug in the US pharmacy that probably achieves all of those with a price ratio of $1 to $100,000 if we had to do an intervention. So I think I think it's environment for those who can, and some who cannot, by the way, are people who were survival of cancer, because when we have cancer, we treat them with radiation and chemotherapy, we age them basically. And they get age-related disease sooner. We know kids that are getting age-related disease sooner. We know women who had breast cancer and they age. They look and they say that they aged through this treatment. So they need help. People who have HIV, they get diseases 10 years before their cohort. They need help. People who are debilitated and disabled and cannot move, and also because of that they eat, they need help. And if we want to go to Mars, we're not getting there before we solve aging. We're never going to get there healthy, and we're not going to make it back. So we have lots of reason beside the elderly to find solution for aging, and we can do that.
Mm-hmm. Absolutely. Well said. And one last thing that I'm thinking about here is, I listened to your podcast with Dr. Peter Attia, which was about a year ago. And I know that so much has changed, in 1 year. So what has really changed that, big discoveries that have been made in the past year? And then also, what are things on the cusp that you're really excited about that you guys are about to break as far as discovery and new technologies go?
Well, so let me tell you, not from my lab, but the biggest thing that we're pushing, the biggest initiative, one of them is the super ager initiatives, right? To get centenarians, get all the genes and start creating therapies like 36, right? Therapy or IGF-1 therapy, and find an indication to target aging with it. The second thing is biomarkers. We have an initiative to do biomarkers on studies that have been done on gerotherapeutics and find what changed within a year of therapy, so that we can see not only what are the biomarkers of aging, but the biomarkers that react to therapy. And third is the TAME study, which is a study that is coordinated with the FDA to show that aging can be targeted, but also get an FDA indication to target aging and prevent cluster of age-related diseases.
Awesome. Great. Thank you so much, Nir, for being on the podcast. You shared so much wisdom and knowledge. I think a lot of people are excited about the space of longevity and what's going to look like in the next, couple of decades. I mean, even this decade, and we're going to make huge discoveries. So where can people find you?
Well, first of all, look, I don't care if people don't find me, as long as they find you. And I really appreciate what you're doing, and you're young, and I think young people can help us more than elderly people. A lot of older adults think, it's too late for me, and it's not. But I think it's important for the young people to know and to push us and to help us through, because we have a wave now, okay? Otherwise, you can find me, okay? But I think more important is good luck to you, and I hope that people find you.
Awesome. Thank you so much, Nir. So thank you everybody for listening, and I will see you in the next episode.